Only 119. Today's strength is 2 less. Okay, still joining. Okay, meanwhile, let me share my screen. Okay, still joining. Okay, we'll start at 8:05. Can anyone confirm today? Do you, are you guys having academics or holiday?
Today Sunday for whole day.
I mean,
CRT.
okay, total entire day is Sunday only.
Yeah.
Okay, cool. Okay, then let's start the session. So from today onwards, we are going to discuss about the linked list. So this coming 4 days, we are going to discuss the linked list problem statements and how it will be. I mean, we need to utilize them. And how many of you know? I mean, how many of you still have fear about linked list and data structures? Like when anyone say data structures, we need to okay, this is having some more complexity than compared to others. How many of you thinking? Okay, let me know one thing. How many of you know linked list programs? No answer for no questions. Okay, cool. Okay, then let me start. So, what is linked list and actually why? Personally, I understood the working of linked list, but don't know where to use them. Okay, cool. Let us see how we can use them. So, like arrays, linked list is a linear data structure. But unlike arrays, linked lists are not stored at continuous location. Okay, the elements are linked using pointers. Okay, cool. It is same like arrays only from the data structure perspective, that is linear, but it is not storing in the same continuous location. Why linked list? Arrays can be used to store linear data of similar types, but arrays having following limitations. What are they? The size of the array is fixed. Correct. So when we are declaring an array, we are having fixed array length. So we cannot exceed that length. Inserting the new element in array of elements is expensive because room has to be created for the new element and data to room existing elements have to be shifted. So what is this? What is mean by shifting and what is this mean by this one? First of all, we'll discuss in a hmm, let me take an empty document. I will tell you what is the main difference between linked list and this array. So okay, if I take an array, suppose I'm storing like this. So okay. So why it is an expensive cost? I mean, expensive operation to do. So suppose if I want to create one more, suppose if I want to create one more, so what happens is, first of all, I need to increase the size. Then I had to add the element. This is one thing. Apart from that, suppose if I delete this element, whatever may be the elements which are present to the right side, they need to be shifted from right to left. If you see this one, every element is shifted, right? Suppose if we have 1,000 elements or 1,000 things we need to do, suppose if I delete the second operation, the remaining 998 elements will be lifted to shift. I mean, sorry, shifted to the left side. This is the costliest operation. That means we are shifting every time whenever some element is deleted or whenever some element is added. Like that way, we are shifting towards right and left. This will be the costliest operation. Then how come array list overcome this problem? So in array list, if I take, okay, this is one. So control V. Okay, let me take one more. Okay, let us see in the PPT itself. Maybe I having some design. So how it is not cost list operation in the array list, and how, I mean, linked list, to to do shift. But if you go to linked list, let me tell you. Yeah, suppose this is the linked list. Observe. Suppose if I delete C or D or anything, instead of shifting the elements, I will do the simple operation where, suppose if I delete B, A next will point to C, and C previous will point to A. Simple. We are not shifting anything. Just we are interchanging, swapping the next values. I mean, the addresses which are pointing to the B will be just interchanged to A and C. That's it. We are not doing any shift operation or anything. So in this way, the linked list will be very easiest operation to do. Got it? That's what the difference mainly. Next, where we use the linked list in real life. So implementing the stack and queues. So why stack and queues, and where we use the stack and queues first? So implementing stack and queues means, suppose um, okay, you are doing some operation where you need to analyze the string evaluation. In the string evaluation, you want to first, I mean, suppose if you are doing some complex operation like mathematical operations, so where related to some big data or anything. So at that time, you want to do the calculation. Do some calculations first, next some actions, again some more actions, like that. If you have any scenario, at that time this tags will be useful more. So for that implementation, we can use the linked list. And implementation of the graphs, so wherever you have the graphs concept, there we can use the linked list. And dynamic memory allocation, we use the linked list for free blocks. I mean, if you want to create the free memory, you can use this one. And maintaining the directory of names, and performing the arithmetic operations on long integers. That's what, if any operation having long arithmetic, I mean, calculations, then we can use the stacks and link stacks by using linked list. Manipulation of polynomials by storing the constant in the node of the linked list. Polynomials, like, means suppose if it is having more characters, like that. Next, application in real world. Image viewer. Previous and next image are linked, hence can be accessed by next previous button. Suppose if you open the uh, I mean, like any images, We show one example. See here, I open this one. When I open this image, when I click on next, it is going here. When I click on here, it is going previous. Like these applications where you are having interlinking, then you can use the linked list. And music player also. You know, right? Everyone use it to, I mean, Wink or Amazon Music or any music player we used to do, right? There also we are having this option. So there also we can use that. And coming to single linked list, what is the single linked list and how we represent them? So a linked list is represented by pointer to first node of the linked list. The first node is called head, and if the linked list is empty, the value of the head is null. That's what correct, right? So initially it will be with one node, and if it is having multiple nodes, the node will point to the next node, otherwise it will point to the null. So each node in a list consisting of at least two parts. One is data and one is pointer. In C language, we will be having pointer, but whereas coming to object oriented, we will be having one more variable which is pointing to the next node. Okay. Next, doubly linked list. So what is doubly linked list? It is having one more field extra to store the previous value also compared to that one. Got it? Next. So first we'll see what is the problem and how we will insert, how we will delete, how we will what are the different insert functions existing, how we need to do these operations. Before going to that, I will show simple example how yeah, okay. Before writing this one, I will show some operations. So in Java, and I mean, even in Python, it has some more features. I'm not sure about that one, but in Java, suppose if we say linked list, new linked list. Okay. So directly you can create this linked list by using this linked list class, which is present in the collection framework. And for this one, you can add, okay, like this, simply we can create the linked list by using the object and we can do any operation. If you see this one, linked list dot, you can see that there are many operations. Adding all, that means if you have an array or a collection of list or array, I mean list of elements, you can add all the elements into linked list, and you can add all at specific position. You can add to first, you can add to last, you can clone the list, you can I mean you can check whether there's some element present in that list or not, and you can iterate through that list, and you can check the whether it is containing all the another list elements, and you can get the first element, last element, whether it is empty or not, whether I mean you can get the index of that list, and you can poll, I mean you can poll peek. These are the different operations which are coming from the queue thing, since in the Java it will be extending the queue class also. So these are all the like deleting, removing at the first, removing at the last, removing at index, like that we can do many operations. Okay, in the Java they are directly provided, it's okay. But suppose if I don't know these operations, if I want to learn the internal functionality of this one, how can I achieve this one? Now let's we see that. Okay. Now you got that in the Java we have linked list class and there you can directly use it. But okay, but coming to the implementation part, how can I create them? So node is nothing but a object or a structure. I mean, normally in C language, how we will create node by using the struct keyword, right? Struct node equal to, and we will be creating the int data, and the next one is pointer variable for the storing the address. Like that we create. But coming to Java, how we will store? Let's see. So in the Java also, instead of structure, every data structure will be defined in a class only. So our in the C language we used to create with the struct keyword, right? But here class itself and a data structure, which can use it to store the data. So here we are creating a node, public int nothing but next thing also it will store the node only. So I'm keeping it as node, and I'm having one more method to display the node data. Okay, this is what node creation. Then let us see how we can achieve this one. I mean, how we can do all this. So similarly, how we created for existing Java, directly I created linked list, right? Because it is existing in Java. I mean, in the util class, it is existing. But coming to my case, I have created single linked list. There is no such class in Java, right? So I have created my own single linked list to implement the things. So I have created this class over here. See here. So for that, I have created object. And if you see the Java linked list, it is saying add, but I have my own method called insert first. So what it is doing? So I'm saying insert first, comma 5. So what it will do? First, it will go to this method and it will create the node first, since it is the first element, right? So first it will create a node, like how means it will create the one node like this one, whatever we have said, this node it will create. And for the data part, it will assign whatever data that we sent. And for the new node dot next equal to head, that means it will point to the head, and head equal to new node, that is nothing but itself it is acting as the head. Okay, that's what happening. Okay, next, this is adding at the first. Okay, cool. Again I'm saying insert first. So what happens here? Again insert first means again it will come over here, again it will create node, and again it will assign data to that one 6. And this time new node dot next equal to head. What is the head? Actually previously the element which passed 5, 5 is acting as a head as of now, but now this new node is pointing to that head means the whatever the 5 we passed will be at the second place, and the new node is head again. So in this way, inserting at the first element is happening. Support insert last. What is happening at insert last? We'll see. Insert last nothing but first it will store the head in some variable in the with this type of node only, and it will iterate through all the elements until it reaches the end of the node. Once it reaches the end of the node, what happens? We are creating the new node and assigning data, and current dot next equal to new node. Since we reached the end of the node, the next will be actually null. But what we are doing, we are assigning the next to the new node simply. Got it? Like this we are representing it. Next, what are the other operations we have? We have delete after. How can we delete after certain node? So first we are creating one node and we are saying that delete the node which is after this data equal to 1. So we have inserted 1 also, right? After 1, what is the element is there? 2. So how we are deleting that one? So if I go here, first I'm checking it should be not null, and uh, temp data is not equal to after the data. That means it should not be the data which is same as this one. So once we are checking this condition until it is false, I mean until wherever we want to delete reaches, we are just iterating to next place. Once we reach that place, we are simply checking if it is not equal to null. We are simply changing temp dot next equal to temp dot next dot next. That means we are just pointing the current element to by skipping one more element, and we are joining to the next element. That's what it is happening. Okay, now let us see how it will works. And we have one more method, insert node at specific position. We are passing data and we want to store the element in certain position. So how it will work, we'll see. Let me do one quick debug implementation so that you will be clear how it will be storing. Okay, let me put in a debug pointer over here. Okay, let me run here. Mhm. So it opened in debug mode. Okay, so first of all, we are inserting at first node, right? We'll see what happens when I say next. Okay, so after inserting first node, how data structure will look like? See here. First it is inserted 5 and it is next pointing to the null. If you see here. Next I'm saying insert 6 at the first position. That means if I insert 6 at first position, 5 should be the second one. We'll see whether it is same or not. See, when I say insert 6 at first position, it is pointing to the 5 and it is moving as the first one. And when I say insert first at 7, so 7 should move to the first. See, it is moving to the this one. When I say insert first at the first position, see here, 1 has entered. When I say insert last 2, after 5 it should enter. See here. And if I say insert is at specific position 20 comma 2, this is 0th position, 1 position, 2 position. Instead of 6, it should be 20 over now. We'll see that also. See here. See what we say that instead of 6, replace that one with the 20. So what happened? That will be replaced by this one. And suppose if I'm saying after 1, whatever the element is there, delete that. So what we are saying, we create a node and we are saying delete after. So when I enter this one, when I print this one, 7 is deleted because after node, what is the node we are passing? Equal to 1. So after 1, 7 is there, that is deleted. Like this it will be working. Is it clear how exactly this is working, everyone? Oh, some questions. Doubly linked list, explain again. Yes, clear. So Ramesh, where you stuck, can you tell me? If you know, if I mean, if you tell me the where exactly you struck, then I can continue from there. Hmm. No response, Ramesh. Hmm? Yeah, you're saying something. Explain again. So from where you missed? If you tell me that, I will explain. Why 20 kept at third position? Okay, 20 is not kept at third position. Initially, this is starting from 0th position. That's why it is at this position. If you observe from 0, it is 0th position. This is first position. This is second position. Normally, arrays start with 0, right? Similarly, linked list also with 0. 0. So it is at second position only. But seems like it is 1, 2, 3 you are counting. That's why it is 3. But count from 0. 0, 1, 2. Got it? Doubly linked list. Okay, I mean, you want doubly linked list program explanation? Okay, that's also simple. Simply what we will do is, Let's create a simple example. Just introduction I missed. Oh, I didn't explain anything much about the double linked list. I said it will be same like array, I mean linked list only, but it will having the one more pointer which will be used to store the previous value. That's it. I'm going to explain the doubly linked list and some more problem statement from tomorrow onwards. Just given a brief about what is the small difference between them. That's it. Okay. What else? Okay. So these are the operations we seen. So as of now, till you, I mean, learn from the C language and learning the lengthy data structures for the linked list and all this. But in our Java only, we are having, let me explain the simple thing. Okay, let me show some example. Collection framework, where is that? Yeah, let me explain some simple thing. So first of all, we need to know the Java collection. So as of now, you learn these data structures. I mean, like lengthy, right? So, but I'm going to show. Let me put in new page. Control C. Tell me when this is clear. Is it clear? The image. Is it clear? The image. Can anyone tell?
Yes,
Yeah.
sir.
Yeah. Okay. Sure. So now we'll see what is the collection framework and how we can achieve linked list without doing certain large creation of classes, nodes, and how we can utilize this. So in the Java we are having one interface called iterable. So before going to that, is the Java classes started for you?
Yes, sir.
Okay. So I think you guys know what is interface then, right? It will be having the only variables and only the abstract, I mean, methods which are not having the implementations. And from Java 8 onwards, we are having some more new features called default to methods and static methods. That is different case. But as of now, assume that only it will be having the unimplemented methods only. So like that, we are having one interface called iterable, and from that interface it is extending one more interface collections. Let's leave about these interfaces and how it is extending. But in the collection interface we are having three called list, queue, and set. Just we'll talk about the queue and set after some time, but see about the list. So in this list we have some other classes. I mean, list is an interface actually, so it is having only an unimplemented methods. So some other classes which are implementing the list. Then why they are implementing the, I mean, list, and what is the use of that one? So list is having some unimplemented methods like add first, add last, add at specific position, like that, remove. All these will be having. So what are the classes which are implementing means array list is the one of the class which is implementing list, and linked list, vector, and stack. These are the inbuilt classes. That's why when I say linked list equal to new linked list, you can see that it has imported java.util.linked list, right? So if I see from where it is coming, it is not opening. Okay, so let me, instead of list, I can say that list. Okay, so if you see this one, it is giving an error. But when I imported util.list, the error is gone. That means list is an interface. Sorry guys, 1 minute. Okay, list is an interface, right? This list is in a parent of this one. That means linked list is implementing the list interface. That's what I shown in the diagram, right? So linked list is implementing the list interface. That's why when I say list equal to linked list, it is importing the two things. One is list interface and class called linked list. So that's why we are able to achieve this one. So whatever the unimplemented methods are there in the list, that will be implemented by linked list. Similarly, we are having one more class called list equal to new array list. Okay. Similarly, linked list. Let me take list one. Similarly, linked list, we will be having array list also, right? What is the difference between both of them then? It will also having add method, it will also having remove method, it will also having index method, everything which is common to linked list, right? So then what is the difference? The difference is array list is same like linked list only, but the main difference is it will not maintain any insertion order. I mean to say that if I say next, it won't give anything. If I say what are the linked elements, what is the previous elements, that we cannot achieve. It is simple like array with dynamic memory. Whereas array is static, right? We will fixedly define that array into new array. I mean int arr equal to new into 10, like 10 elements only. But in case of array list, it acts as same ditto as array, but with the dynamic memory. And compared to linked list, it doesn't maintain any insertion order. That's what the difference. So when we use to linked list, when we use array list, is depends on our, like if you want to like do some searching operation immediately, when we will go for link array list, because searching will be easy in the array list, because it will be maintaining in the index, right? Directly we can pause the index and we can get. But in the in the linked list, why it is difficult operation means, when I say a certain element to search, it will traverse through the each and every node until it finds that element. Whereas in the array list, directly based on the index, it will get it. That's what the main difference between array list and linked list. Based on this scenario, if you want this, if your application having the searching functionality more than the insertion and deletions, then you will go for the array list. But suppose if your application having not priority to the searching, but insertion is deletion should be fast in your case, then you will go for the linked list. Because why we are going for linked list for insertion and deletion? Since for insertion or deletion, it will just interchange the pointers but does not shift the elements towards right or left, right? Whereas in the array list, it will shift to the right and left, right? That's what the difference. Like that, in the Java, we are having these type of classes which will provide us the direct implementation of linked list without doing this one. But if I want to do the things which are present in this linked list, I can do the all operation like this. I can write my own logic to this one. Instead of, you suppose if you don't want the Java util class util package methodologies that you provided, suppose if you want to achieve something else from this one, you can directly implement the linked list in this way. Is it clear for everyone? Response please. Is it clear?
Yes, sir.
Okay, cool. Yeah, next one is this is what we have discussed. Insertion of the front of the linked list is nothing but adding at first, at given position, at the end of the linked list. Okay, next one is, so this is what inserted beginning is. We have already seen the Java program, but how diagrammatically we can represent it means, initially A is the first element, but when I say add at first, this will first create a node and it will point this pointer to this one, and it makes this node as the head, like this. This is theoretically and diagrammatically, but that is practically. So inserted position means first it will traverse to certain position, and after that what it will do, instead of pointing to B directly to the C, it will cancel this one and B will point to E and E will point to C. Like this, it will insert at specific position. Inserted end means directly it will go to the end of this one and it will print the, it will directly point that node which is pointing to null. is shifted to this E, and E will point to the null. We can say that this is simply swapping thing. Next, at the same like how we inserted, this is delete operation. So how we are deleting means deleting at the front, deleting at given position, and deleting at linked list. I mean, sorry, at the end of the linked list. So we said delete it after a method only, but I would suggest you people to write for deleting at the first point and deleting at a certain position, or deleting it at the last position. How you will delete means simply traverse up to that one. If you want to delete last element, traverse up to end of the linked list, and just point that the before one to the null. Simply, that's it. If you want to delete the first node, simply remove the head, I mean place the head in some temporary variable, and point head to the next of this one, and make this first node next pointer will be null. Simply, do you want us to, I mean, do you want me to write the program, or you will try for that one? Response. You people will try, or do you want me to write? Will try. Okay. Okay, you only explain. So one vote is for explaining, one vote in will for try. Let us see. One shows the code. Will try later. Will try first. Okay, let me show whatever I have written for insertion. Based on that, you will try for the delete. It will be better if you try. See, this is the one. So I explained for delete it after. That means it is at certain position I'm saying. So for that one, what I'm doing, I'm traversing up to the end of the, I mean, before the element what he said. I'm just suppose if I have 10 elements, if I say delete it after second position, I will traverse up to first position only, and then after I will delete it like that. And it should be, I'm checking two conditions, that the next element should not equal to null. If it is the next element itself is null, there is no such element present, right? So then I don't need to delete. Suppose if I have only five elements, if I say delete the element after fifth node, there is no such element. That condition also we need to check, that whether the pointer whichever pointing to next is equal not equal to null, then only we need to move forward. If it is equal to null, then we can break the condition, and we can say that there is no element present after this node. Simply. And one more is temp.data not equal to after.data. That means whenever we are moving the forward direction, we should check one condition, that whenever we pointed to this condition, like we are saying that delete after node which is having one data. So whenever we are moving further, we need to check that whether data is having one or not. If it is equal to one, then we need to stop there, and the next one we need to delete. That's what the we are checking at the condition. So this is at specific position deleting. But if you say deleting at the last position, how you will try means simply check until temp dot next not equal to null directly. Don't need to check this one also. This condition itself not needed. Just check only this condition. Break the condition before it is equal to null. Then you will be ended at the last one, right? I mean last one. If it is not equal to null, that means last one. Not equal to null, I mean before equal to null means just before the last one. So what you will do, for that one you will point to the null, and remaining well, you, I mean once you point the before one to the null, the last one will be deleted. Simply. Got it? Simply like this. Public void delete last. Okay, not needed. Node equal to head. We are pointing to the first one, and while temp dot next equal to null, what we are doing, temp equals to temp dot next. Okay, So what it will do means it will traverse up to temp dot next equal to null. It will move up to that one. Mm, Instead of that one, we can say temp dot next. I mean, we need to stop before the one. So whenever I reach this one, I simply say that temp dot next equal to null to assign this thing. That's it. This is what deleting at the last position. Let us try with this one. We'll uncomment our code and we'll try. So let me do this operation. My linked list dot delete last. I'm calling this one. After that, I will print this. What happens, we'll see. Okay, okay, it is directly pointing to this one and making it null. So I think something we have written wrong. I need to traverse and do right. Let me check once again. Temp equal to head, while temp dot next mhm, not equal to null. Sorry. Let us see what happens. Yeah, see. So it traverses up to the last one. That after that it is pointing the next one to null. That's why 2 is not representing here. 2 is deleted over here. This is how we need to implement. Clear for everyone? How we written this logic? We are checking before going to the last element. We are checking the one more element before only. I mean, suppose next, instead of checking next element null, next dot next. That means two steps before what happens, we are checking. If it is null for the two steps before, we are making next equal to null simply. Got it? Clear for everyone? Okay, cool. Next one is, this is what I have written. I mean, deleting it first, deleting it last. So next problem is reversing the linked list. Okay, so for reversing linked list, what we'll do? So input is suppose if we are having 1 2 3 4 and linked list should be changed to 4 3 2 1. How we will achieve this one? So how we will achieve means simply what we will do is, first of all we need to traverse to that last element and make the last element to be head and first element to be point to the null simply. We'll store the first element in a temporary variable and we'll traverse up to the end and we'll make the last element which is pointing to null as the head. And after that, before doing that, we need to shift the pointers also towards right. Suppose whatever the first element pointing to this one, let me take an example. If you see the solution for this one, whatever we have given, see, before reversing I can make 5 as head immediately by traversing, but the pointer also should point to 20 and this pointer should point to 1. How we can make it? So I would suggest you guys to take it as a home task and complete it. And tomorrow we'll see how exactly it is working, so that if you people not unable to solve it, tomorrow again we will solve this question from scratch, like from creating node, how we are pointing to the left and how we are using logic, exactly how we are performing this one to the right and left node. That everything we will discuss tomorrow. Is it okay? So we can use stack to reverse the linked list. You can use any logic. There is no restriction for you guys. You can use anything. You can use the linked list also. You can use stack also. I mean, mean to use the stack means you want to implement the stack operation, and you will mean to say that, I mean, since it is implementing the I mean last in first out, you want to do like that operation. You can do that also, but I would suggest in I mean, if you want to know the internal implementation of linked list, better I would suggest do in this manner, like how you will shift the pointer to the backwards. So that what happens means you can use the stacks and use whatever you have directly, you can use it, but what you will learn at the end, that need to be important, right? So first, I mean, you can use the, even in the Python you will be having, I mean, if you want to use the stack, instead of that one, I can say that if I use the Java list, I have one method called list.reverse that can do my operation easily. But we can use these ones once we know the internal implementation. Once we know the internal implementation, we know how it is working, then if you use the shortcuts, then you will even you know the internal functionality and you are using it. If anyone asked you, you are able to explain the how list.reverse is working in the java.util, right? So I would suggest you guys to write the logic of internal implementations of the reverse operation. Are you getting my point? Okay, so tomorrow I will check any one of you randomly. I will pick and I will ask you to share the code. Otherwise, you can post over here. I will ask that how you have, I mean, achieved this one. What is your logic behind this one? I mean, how you approach it to this question. So I will ask anyone randomly. If no one done, then we will do it from scratch. If anyone done, I will encourage you guys to explain to the entire team how you approach, so that your, I mean, whatever the stage for your communication skills will also increase to explain you, I mean, explain to the entire team. Even if you go to the interview, you will be like clear that so I have explained in front of 250 people. It is not a matter to explain to the one person, right? So like that also you will get some confidence. You mean reversing a linked list without using the reverse method? Exactly. I want the internal implementation of reverse method. We have reverse method, but how it is working internally, that I want you to write. Okay. See, I will write for you. Okay. Thank you guys. Tomorrow we'll discuss the reverse program, and if anyone, I mean, no one will done. After that, where we will go means uh, check if the link. Okay, tomorrow I will discuss the linked list which is having loops or not, and also some of the problem statements, how we can solve this regarding to some statements. We have some more. We'll discuss them in the tomorrow class. But I will encourage you guys to write the program once you are like easy. I mean, you feel comfortable to write this one, so it will be very easy to for the next programs. Thank you guys. Thank you so much.